All right, so I think it's about time, but this is the How to Use Citizen Science for Virtual Research Experiences webinar. And we have a lot of interesting groups here today, different panelists that are going to talk from SciStarter, Blue Thumb, Oklahoma State University, North Carolina State University, and Rogers State. So to get us underway today, really quick, if you haven't yet, go ahead and introduce yourself in the chat. So your name, maybe where you're from, what you do for a living. And I believe we have some poll questions that we're going to ask you here in a minute to try and see who's in the audience today. Wow, Nebraska, Florida, New York, Oklahoma, awesome. Peru, wow. That's pretty impressive. All right, so I believe Dr. Asino has some poll questions that you should be able to see here on your screen. Go ahead and click the options that apply to you. Firstly, have you participated in citizen science before now? Are you considering any virtual research projects this next year? And which of those listings describes you?
It's coming up at a minute. We have about 75% people participating. Not a bad survey response rate.
Awesome. So have you participated in citizen science? There's a pretty good majority of people who have, but also many who haven't. It looks like a lot of people are considering virtual projects for this year, and a lot of faculty and research and some undergraduate students here today. That's awesome.
And shout out to the librarians.
Hooray. Well, cool. So I'm going to briefly introduce the panelists before we jump in today. You'll hear more from them directly, and I'm going to let them introduce themselves more in depth here in a minute. Just briefly, I'm Cheyenne Olson. I'm from OSU and RSU here in Oklahoma. We have Carolyn Nickerson from SciStarter, and it's actually her birthday today, so we're glad that she could come on her special occasion. Brianna Johns is representing North Carolina State University, and then 3 people from Blue Thumb, which is here in Oklahoma, Rebecca Bond, Kim Shaw, and TJ Pullen, and finally 2 undergraduate students from Rogers State University who will talk about their research. So thank you guys for being here. I'm excited to see all the different panelists and hear the things that they have to talk about. Just quickly, a timeline of how we're going to get through the presentation. I'm going to start with a brief introduction to citizen science and why it's useful in undergraduate research. We'll have SciStarter in North Carolina talk for a little bit, Blue Thumb, our undergraduate students, and then question and answers at the end. So throughout the webinar, if you have questions that you want to ask, you can type them in the question and answer box. And theoretically, the other panelists who are not presenting should be able to go and answer your questions there. And if we have time at the end, we can get to anything that we missed. So jumping in today, there's been so much discussion this summer about citizen science, especially after Citizen Science Month wrapped up, and there's been a lot of push for virtual experiences due to COVID. So I thought we should start by addressing what is citizen science. And I really like this definition that the Citizen Science Association has been using. but it says projects that involve non-scientists and the processes, methods, and standards of research with the intended goal of advancing scientific knowledge or community action. So citizen science is really engaging non-scientists or scientists and students in the process of ongoing research that's happening. So our webinar today is going to touch a little bit on how this is useful for research at the undergraduate level, ways that you can have virtual research experiences when you aren't afforded the opportunity to be in person, and then some different examples of how this is being implemented right now. Really quick, I won't cover too much of this. SciStarter might cover more, but if you're not familiar with what citizen science projects cover, I just want to give you kind of an overview of it. Citizen science project scopes are from the individual to the global level. So there are projects that focus on individual data collection in your local community, that focus on solving a singular problem, all the way to efforts that span the globe and all the different countries working together on a research question. Discipline-wise, you may be more familiar with the environmental and the macro-focused projects like the Christmas bird count, but there are micro-focused projects as well. So there are projects available where you look at pictures of bacteria in petri dishes to look for antibiotic resistance. Some of the ones you see on the right are pictures taken from telescopes where you get to map out galaxies and star constellations. So it's such a wide-ranging field. Activities for participants range from collecting data themselves, so either virtually analyzing data or going out in the field to analyze data, doing interpretations of that data, and has been used for publications. So many research publications use citizen science data to promote the research questions that they have. The focus of a lot of talk this summer has been on why should you use citizen science in higher education. So if you aren't familiar, the Citizen Science Association had a series of round talk discussions this summer about how to use it. These webinars covered how do you find a project, how do you incorporate it into a class, so I highly recommend you check them out. But what we've seen is that citizen science can be used in a variety of ways in higher ed. For some universities, it's an entire course where students are basically participating in multiple projects as volunteer hours. Some educational courses just use it as an assignment or a one-semester type research project. And kind of what we're proposing today is using it as a long-term research project. So if you're a university that has a capstone project or you're encouraging undergraduate research, citizen science could theoretically fit that role as well. And there are so many benefits to doing this, benefits that have been proven by current research that's ongoing. There's increases in knowledge and practical skills for the students directly who participate in this. One thing that we're promoting today is that it gives an at-home field or lab experience. So it takes students out of the classroom setting or the traditional lab setting and gets them actually doing research elsewhere. So this leads to more inquiry-based learning, where students are really coming up with their own research questions and pursuing those rather than coming up with questions or being led to them. So we say normally there's kind of this traditional apprenticeship model with research, and this is really common across many universities where students are conducting research directly under a supervisor or directly under a faculty mentor. So that's either in the lab with the mentor or the mentor goes out in the field with them. But citizen science now is providing us this virtual or field experience that's possible as well. So you'll learn from SciStarter here in a minute, but there are actually citizen science projects that are 100% online and virtual. So students are able to collect data, analyze data, and monitor it via an online format. They never actually have to leave their house in order to do that. And we've seen that this has been increasingly important since we had the COVID situation, where many universities had to switch to a virtual or an online format, and students weren't afforded the opportunity to go into the lab or to go out in the field. So there is the virtual component that students can use as well. Some other projects provide a field component. So for students who want to get out of the lab setting, things like Blue Thumb train participants how to go out in the field and collect data on water monitoring, air quality. So rather than have direct supervision from a faculty member, students are encouraged to do their own data collection and their own monitoring efforts, and then come back to the faculty member and be engaged. So what are we proposing? Well, that citizen science used as an undergraduate research tool has a lot of benefits for the students directly. So for one, it serves as a tool for students to gain useful and relevant knowledge. They're gaining hands-on skills and issues that are either local issues, community issues. So again, using the water as an example, they're learning techniques in water monitoring that can be applied to a later career or to help them further their research goals. I think that using citizen science for undergraduate research promotes awareness about local issues. So they are working in their community to solve a problem that has been addressed. It's a means to connect to the community, to learn about what's current and ongoing. So a lot of these projects have issues that are being addressed in real time, current issues that they want to address. And again, it provides this beyond the lab experience where students are getting out of the university, going out in the field or going virtual and collecting data without having to be directly supervised to do that. And in the long run, I think that leads to career opportunities for students who can take all these skills that they've gained and transfer that to a job. There are some things to consider and some possible challenges with doing this and starting to implement this citizen science component to using it for research. For faculty who are here today, you probably have to be a little bit engaged in the process. So just like you would normally mentor an undergraduate student doing research, you need to be a little bit familiar with the citizen science projects that are available and how they work. Specifically for your student, what type of data do they get to collect? How hands-on is it? The quality of the data, time and cost involvement. So it does involve you having to get familiar with which one your student is doing. Citizen Science Association brought up this point that it's important that while you use citizen science for your undergraduate research projects, that you still promote the overall goal of that project and whatever research questions that project has as well. So I say that's just making sure you're working closely with the administrators of those projects to make sure that you are following their research goals and guidelines. I think there are some issues to think about when it comes to the access and use of data. Some citizen science programs that are completely online have open data sets where you can actually go and pull the data that you need for analysis. Other ones you probably need to ask for permission, of course, before you use, consider what the data is going to be used for, and address any kind of privacy or ethical concerns that come with signing up for these projects and using the data that other volunteers have collected. And when it comes to the data from the projects, things to consider include collection techniques. So whether the student is being trained by the citizen science program or by you, whether they're being monitored when they collect the data or not, and the quality of the data that is collected, ensuring that it's high quality, good for research publications. But looking forward, we think there's a lot of potential successes with incorporating this. For students, like we said, they are directly gaining applicable skills to help them with future careers and gaining an awareness of the field. For faculty, this provides you with the experience of mentoring students with undergraduate research projects and having to use fewer resources, so saving on that time and cost commitment, but also having a way to engage your students out of the lab or having a way to engage your students where you're letting them be more self-led. For citizen science program administrators, this would allow them to gain participants that are technically skilled and innovative. So these students that come to them have an educational background, may already have a skill set level that can contribute to the question or project that that citizen science program wants. And for campus communities, campus-wide, this is allowing your campus or university to work directly with the local community on ongoing issues and research that are important and contribute to real change. I feel like for students, this is a very hands-on way to see that their research is actually fueling real problems and real data. Now, if you're curious about where to find projects or you want to learn more about it, there's a ton of citizen science resources you can look at online. These are just some of the large databases that house different citizen science programs. So if you want to go browse programs, we will send out a list with these websites. I highly encourage you to check out the Citizen Science Association. They, again, have a webinar series about how do you find a project for a classroom? How do you assess participation? So if you're interested in using it as a one-time assignment, you might look at that. And then finally, we're going to talk today about SciStarter, which is going to be a method of looking up projects online, housing them, and even monitoring student activity there. So having said all of that, I'm going to stop sharing. I'm going to allow Carolyn to tell us more about SciStarter today.
Yeah, thank you so much, Cheyenne. And thank you for that wonderful introduction. I'm going to share my screen and start sharing. It was so great to see all those different resources just now up on your screen, because the great thing about citizen science is we grow by connecting. So for example, with Anecdata, which is a platform where folks can make their own citizen science projects, Anecdata projects automatically become SciStarter affiliates. And same with CitSci.org. We bring in those projects to SciStarter, and Zooniverse project leaders also often add their their projects to SciStarter, and sometimes choose to become affiliates as well. So I'll explain that in a sec, but I just wanted everyone to know that it's such a delight to be able to be so collaborative, and I think the citizen science community is uncommonly like that. Real go-getters and bridge builders. So, and you all, just by being here, you've joined the citizen science community as well, so thank you. And first and foremost, hello. My name is Caroline Nickerson. I'm the program manager at SciStarter, which means that I get to spend my days doing things like this, talking to people about citizen science, and often doing citizen science and learning about cool projects. So it's just an absolute dream. And I think most of you on the line know what citizen science is, and you definitely know what it is after listening to Cheyenne's awesome explanation of it. But one way I like to think of it is as a collaboration. So it's a collaboration between researchers and members of the public who want to make a difference. They want to turn their curiosity into impact and learn more about the world. In SciStarter, we see our role as a connector between those millions of people who enjoy science and nature, the thousands of scientists who need volunteers, who can't really find each other without a bridge. We want to be that bridge. So for our process, we do a number of programs. We work with universities, schools, lifelong learning programs, the Girl Scouts, corporations like Verizon, to bring citizen science to those communities. And that's why we have different tools. That's why we work so hard to, research citizen science itself, including with NC State University. They help us analyze all the data we have on SciStarter to kind of understand the field itself. That's why we strive to evaluate ourselves, see how well we're doing in our programs, and why we don't want to divorce ourselves from the societal, economic, and cultural context. That's really important too. It's a real ecosystem here of all these different things. But the core of SciStarter is the website itself, where people can search projects and people can add projects. So a project like Blue Thumb, for example, they would create a profile on SciStarter with different fields. Like, maybe they'll tag their location, so Oklahoma. They'll tag, what the thing is, so water, where people could do it, the amount of time it might take to participate in the project, and all these different search terms. And then folks would be able to use the SciStarter Project Finder to search for it. And so there are over 3,000 projects, events, and tools listed on SciStarter. So it's the place where the citizen scientists can find the projects, events that need their help, and the tools they can use to do these projects. The Project Finder, there's a simple search and an advanced search. My favorite, for people in the room, the thing that might be most useful to you for the Project Finder is the Has Classroom Materials field and the Age field. So I think a lot of people who are here are college instructors. So you may want to search for projects that are college, Has Classroom Materials. And you could also, for example, select online only. Let's say you're completely virtual in the fall and you want to find a way to engage your students in real scientific research. You could partner with a citizen science project that has already thought about, that pedagogy, that classroom materials component that's really targeted at college-age folks and that's completely online. So the Project Finder is your resource for that. And then for the individual side of things, every SciStarter user has a dashboard. So this is my dashboard. It's from a while back. So it's when I'd only joined 13 projects. That has changed a lot. In your dashboard, you can find recommended projects for yourself, track your contributions across projects, and you can display your profile and accomplishments. So that's where the affiliate program comes in. There are quite a few projects that are SciStarter affiliates, meaning they've opted into an extra level of tracking. So folks can track the number and frequency of their contributions to these projects in their SciStarter dashboard. So for most of these projects, people go off SciStarter to do it, right? So something like Stall Catchers, which is an Alzheimer's research project, it's completely online. Folks are making those annotations on the Stall Catchers platform. But because it's a SciStarter affiliate project, if you use the same email for both, it automatically tracks in your dashboard. It says you made 7 contributions on August 8th or whatever you did. And that's really helpful for instructors if you're trying to give people credit for participation or to verify that they did indeed volunteer to advance scientific research. You're able to do that level of tracking. If you're looking for projects to feature in your classroom, we recommend the scistarter.org/education page. We made this in preparation for COVID, especially because we knew that so many people needed new online partnerships. So their Monkey Health Explorer, that's actually a Zooniverse project. They've done such an awesome job engaging students. Their Crowd the Tap, that's based out of NC State. That's an awesome project, really simple. All you need to participate is a penny and a magnet, and then you can start helping create a national inventory of tap water pipes. And there are so many other projects. I mean, citizen science is so diverse. It's everything from astronomy to zoology. Just as an example of a project on the education page where you learn a little bit about the project and then you click participate to go off and do it. And I'm going to quickly show you, we made this new feature. It's in beta. We just debuted it this week, but you can make lists for people. So I called this list my favorite projects, and I just made it this morning. So only 2 so far. We have Stall Catchers, which I just mentioned to you all, Alzheimer's research online only project. And then Blue Thumb, which you all are going to hear about later in this presentation, which is an absolutely awesome water quality project. So when you make a list on SciStarter, you can, provide a note. So I called this, these are projects I do often with my friends, but let's say you wanted to make a list for a particular class. Like, let's say you're teaching an English class and you want to teach folks science writing. You could call this, English 101, and you could say, hey, students, please pick a project from this list to write about. And submit it to me on this date. And you can also, on your list, you can add notes about the given project. So I said here, Stall Catchers is one of my favorites. And then I said over here, who wouldn't love Blue Thumb? And this is the really great part for educators. So I assigned this to my friend Yang, and she kindly did 3 contributions on SciStarter to show that you're able to see the number of contributions folks have done since they were added to this list, or since they looked at this list. And you can also see the number of contributions they've done since they joined the project initially. So Yang has been doing Stall Catchers since January of 2019. She's made 33 contributions. But this morning, on July 10th, she made 3 contributions after she viewed this list. And you can also download the data, which is, I think, really important for educators as well. And a really important point about privacy, before I show you how to quickly make a list, is everybody on SciStarter who has a profile, they're supposed to be over the age of 13. That's one of our requirements. And your profile is public unless you opt out. So you're allowed to have a private profile, and if you've opted out of having a public profile, it wouldn't show up on this list. And so just really quickly, when you want to add something to your list and make a list, you do it on the project page itself. So let's say I want to add Clean Our Watershed, which I believe is an Anecdata project. I would just click Add to my list. I could type to create a list, or I could add it to my favorite projects. So that's simple enough. If you have questions about it, feel free to tell me or to get in touch with me. I'm always happy to chat. And then I'm so excited. We have all these different free tools. The lists are free. Dashboards are free. They were supported by a number of different projects, some NSF projects, different projects with different folks. But NC State, we've developed a special partnership with them, and we built them this portal for their students. So this is a special private thing on SciStarter just for NC State. The tools I just showed you all were public. But now I'm going to introduce Bree, and you can see that NC State's had a number of their schools participate on SciStarter, which we love. But I'm going to introduce my colleague Bree from NC State, who's going to talk to you all about the Citizen Science Campus and how they've taken it to the next level.
Hi, everyone. My name is Bree, and I recently graduated from NC State with a bachelor's in zoology and a bachelor's in international studies. I am a founding member of Citizen Science Club at NC State and have worked really closely with Dr. Karen Cooper, who has written numerous papers, books, and done a ton of research on citizen science. So we both have been involved in the citizen science movement for quite a bit. And we've worked together, both me as an undergraduate and her as a professor at NC State, to make NC State the first citizen science campus. So, okay. The next slide I have, it shows how students on campus, when you go to university, you can do several things in your free time, several hobbies. You can play sports, you might do outdoors stuff, you could do community service, enjoy the arts, be in theater and things like that. But the question that Dr. Cooper and I had is, what about science? So what about students who have a passion for science and view science as a hobby? So that is what led us to create the Citizen Science Campus. And here, let me pull up. Hey, Caroline? Yeah, and then one more, please, thank you. Awesome. So that's what led us to create the Citizen Science Campus. And the purpose of this campus is to basically get undergraduate students connected to citizen science as possible. It includes university courses, student organizations like Citizen Science Club at NC State, residence halls. So NC State has places on campus called living and learning villages, where students can, like, for instance, there's one called the Eco Village, where these students join this village, they live there in this dorm, but they also do community service or hang out and have like environmentally friendly projects that they do together. And we partnered with them as part of the Citizen Science Campus to allow for students to do citizen science projects in their dorm, which is really fun. And it was Crowd the Tap, the project that Caroline mentioned before as well. And then also libraries. So the next slide I have talks a little bit more about courses and research. So at NC State is a very interesting place because we have a lot of faculty who have been doing citizen science projects, which in turn provides a lot of opportunities for undergraduate students to get involved in citizen science research. So we recently created a magazine, and it's on our website, which will be on the last slide that I show you. And in that magazine, you can see about 17 citizen science projects that are run by faculty at NC State across 3 different colleges. And you can also see the classes specifically in this magazine that are teaching it. And it ranges from English classes to like environmental science, English, even some of the harder, or like, I guess the hard sciences like biology and things like that. And right now, Dr. Karen Cooper has had the opportunity to teach a class to 5,000 incoming freshmen as part of NC State's introductory course called Wicked Problems, Wolfpack Solutions, where she is teaching them about Crowd the Tap and different citizen science projects. So in this introductory course, students are getting firsthand experience of citizen science, which is really exciting. We haven't seen that before. And then on to the Citizen Science Club. So this is my particular favorite slide because I was one of the founding members for it, but student organizations provide a really unique opportunity for students to have a sense of agency over the citizen science projects they're choosing and participating in. So as a club, we would decide and work on projects collectively. We would reach out to faculty on campus and hear about internship opportunities because of that. So a student organization is kind of a win-win all around because faculty who are doing citizen science now have connections to a group of students who are interested in participating. And on the flip side, students who are interested in doing citizen science can get in touch with faculty that are doing these projects. And also it provides like a really nice space for students to be with their peers and to talk about, you know, science, their hobby, like what they enjoy, and feel like they're able to do that with peers and have friends over it. Like some of my best friends are from this club. So it's a really, really good opportunity for incorporating citizen science into university life. And then the last aspect of the Citizen Science Campus at NC State is libraries and citizen science equipment. So we, around Thanksgiving last year, we set out these tiny kits for Crowd the Tap that students could take home for Thanksgiving break. They were distributed at the libraries, and that was a great place to do that because, you know, at NC State's libraries, you're going to hit students no matter what their degree is, and they can pick up these kits, bring it home, and then obviously participate in this research. So libraries are a really great resource because they are a part of students' lives, regardless of their major, on all aspects of campus. And some future ideas that we have for the libraries is having actual little vending machines where students can pick out a citizen science kit, take it, bring it home with them, bring it back to their dorm, things like that. And also the libraries are a great resource for renting out citizen science equipment like wildlife cameras or kits for like stargazing and doing astronomy research related things. So yeah, I think that touches on everything. I think I had one more slide just with our basic contact information as well. And our website is, our website is just citizenscience.ncsu.edu. And our magazine is up there and you can click on it as well. And I think these slides will be shared at the end too. So tons of resources. Yes, thank you, Caroline. So yeah, thank you.
Oh, great. That's awesome. So, beyond the classroom, even a whole campus doing citizen science. That's awesome. So we've kind of talked about like, what is citizen science and why it might be good for using it with research. We've talked about now some examples of how to find projects through CitStarter and what a campus community could look like if they incorporate citizen science. I'm now going to turn it over to Rebecca Bond, who's the director from Blue Thumb. She's going to tell us about a Oklahoma-based citizen science program and how they can be used for this type of work. So Rebecca, the floor is yours.
Okay, see if I can share my screen. Just 1 second here. Okay, so thank you for the opportunity to speak a little bit today, this morning or this afternoon, depending on where you are, about Blue Thumb. We are a water quality monitoring program in Oklahoma. We support a network of citizen scientists who collect data on local streams. And one reason that might be really helpful to undergraduate students is we train our volunteers. They go through 16 hours of training. We provide year-round support. And we also provide all the equipment and reagents necessary to complete the data collection. So just a brief overview of the type of data we collect. Our monitors collect chemical data and stream-side observations monthly. They typically do that independently, and you can see the parameters there that they collect. We assist our volunteers with a collection of biological data and habitat data. So macro invertebrate collections are completed twice a year, and then we do fish and habitat assessments once every 4 to 5 years. And we collaborate with our volunteers to get those data collections done. So how might students access our data? You can submit a data request to our record specialist. Her email is right there. You could also just contact anyone on the Blue Thumb team and we would be happy to facilitate that process. And if you are primarily interested in fish lists or data interpretations, you can go to the Blue Thumb website and all of that is available through an interactive map. I'm not going to navigate to our website right now because we just have a little brief period of time, but it's pretty easy to get around. So I'd like to spend just a few minutes talking about how some of our volunteers use Blue Thumb in their work with undergraduates. So this is John Harrington. He teaches at OSU OKC, and in his introduction to geology class, John shares data about the Spring Creek watershed and the history of oil and gas extraction in that watershed. The students look at chloride data and then kind of explore how those two things are connected. And they're often surprised to find out that chloride rarely exceeds the criterion in Spring Creek. And when it does, it's usually related to road salting, not oil and gas activity. Another one of our volunteers is Dr. Curtis Cole. He has worked with over 300 undergraduates with Blue Thumb data in 4 different institutions in 3 states. At Comanche Nation College, he teaches a class related to the Native American perspective on water and how Native Americans might view data. At Cameron University, his students collect water samples and then analyze them for parameters that are pertinent to wastewater and water treatment plants. And they do that with 2 separate methodologies, the Blue Thumb methodology, and then one provided by the university. And then they compare the results of those 2 methodologies and talk about how those parameters actually impact the biology in the stream. At Columbia College and Upper Iowa University, Dr. Cole has used Blue Thumb data in his Intro to Environmental Science and Intro to Geology classes. He demonstrates some of the lab techniques and then talks with students about how those data could be used further in research, and encourages them to explore citizen science and Blue Thumb in particular as a way to take concrete action on behalf of the environment. So this is Beth Landon, another one of our volunteers who teaches at Oklahoma City University. She has 2 courses where she uses Blue Thumb data. In the first class, students collect data over a semester. They do a macroinvertebrate collection. Kim, who's going to speak with you next, comes out and teaches the students some fish ID, anatomy, and physiology. They learn how to calculate multimetric indices to assess fish and bug data. And then she puts all that together with some of the federal laws surrounding surface water in the United States. So it's a really comprehensive experience. And then in her independent study, students spend 6 weeks looking at data, Blue Thumb data that were collected on a stream. They analyze and interpret that data. And the end result of that process is a volunteer data report that is then posted on our website for the public to access. And then finally, we have Dr. Cothran at Southwestern Oklahoma State University, and his students collect Blue Thumb data during his invertebrate biology class. And kind of a neat aspect of this class is that the students gain surface learning hours, and any student at SWOSU that has 9 or more surface learning credit hours when they finish their coursework receives a special blue honor cord on graduation. So that's kind of cool. So those are just a few ways that our volunteers are using Blue Thumb data in their work with undergraduates. And I'm going to hand it over to Kim Shaw so she can talk just a little bit about our QA procedures.
Okay, hello. My name is Kim Shaw. I'm the Blue Thumb Quality Assurance Officer. And here's a slide. Even though our data is citizen science, it still is a lot more reliable data than just somebody going to hop.com, which is where we get our test kits from, hach.com, and doing stuff and entering it into a database somewhere. We have a lot of quality assurance built into our program. Here's kind of the majority of the list of them. Our volunteers do conduct duplicate samples for each test on their creek water that they monitor. We do incorporate lab blanks. We have all sorts of rinsing procedures to make certain that the equipment's clean and such like that. We have quality assurance meetings, which are mandatory, so it's not like we're, our participants go through a 2-day training course, and it's not like we say, hi, welcome to us, we give you a test kit, and then we let them leave and never see them again. We have a lot of interaction with our volunteers, at least 4 times a year, if not more. And so these mandatory QA meetings are important to make certain that we test our volunteers against known standard solutions. Rebecca, if you want to go to the next slide, please. Thank you. So we host our quality assurance meetings. We try and get them centrally located to about where we have numerous different monitoring groups. So we're not just meeting one-on-one. We can kind of get a couple of them meeting together. At least one person per team needs to attend. For our summer and winter collections, or for our summer and winter QAs, we're out on the creek site with our volunteers doing bug collections. And then our spring and fall ones, our QA is indoors, and our volunteers test against known standard solutions. Also at these QA meetings is when we have any sort of announcements. We've occasionally, thank goodness it hasn't been too much, but we've run across some bad reagents. We'll look at lot numbers and make certain people have good ones. We have handouts of the results from their previous biological collections. We'll restock anything and everything that we initially give out with the test kit, pretty much mainly reagents. This is also a good place for volunteers to meet up with other volunteers and just chit chat and say, hey, how's it been going at your creek site? So have you had any difficulties or anything like that? So our chemistry part, it is citizen science. It's not lab grade. It's not in accordance with the Clean Water Act, but EPA does see our data as more than just somebody going out and getting the equipment. We do have a great QAPP built into the program. And but that being said, our biological is in accordance with EPA and the Clean Water Act, because it is staff that's coming out to the site with our volunteers and doing it in accordance with how our other field staff do it and such like that. And we've recently been working with pathway students that are getting into our, or potentially want to get into our conservation district offices and NRCS fields, and we've been bringing them out on fish collections just this summer. So I think that's pretty much the short and sweet for me. I'll pass it off to TJ, I believe is next.
Howdy everyone, my name is TJ Pullen. I am interning this summer with the Blue Thumb program. I was kind of helping out with our fish collections and other stuff, but I am going to be a senior this upcoming fall at Oklahoma State University. I am majoring in fisheries and aquatic ecology with a minor in wildlife ecology. But just so, like Rebecca kind of mentioned a little bit earlier, with the different data that we have, and how we collect that data with our fish collection here in the one picture of myself and another member of our team holding a seine. We go through a river and try to seine as much of it as we can, 400 meters of a given site. With our macroinvertebrate data, you can, for pretty much all of this data, you can use it to, I guess, just look at the numbers or look at density or whatever's in there, or what is present, what isn't present, or you can kind of use all of it together to kind of make an overall assessment of the water quality. Here in the bottom picture, we have some of our volunteers. They just went through one of our trainings, and they're doing, I guess, kind of a QA of sorts. They're kind of we're teaching them how to do our chemical assessments. All right, Rebecca, if you could go to the next slide, please. All right, so now when we are out in the field doing our research, we can also help our volunteers to come, and you can also come with us, and we can show you how we do our methods and how you can use our methods in whatever given research that you would like to apply to yourself. So our habitat assessment, we go through 400 meters of stream, look at what's in the water, what's outside the water. And our fish collections, like I mentioned, we seine 400 meters, try to seine as much of the stream as possible, and we'll seine over a given area until we don't catch a new species, and then we'll keep moving on down the stream. With our bug collections, we try to sample from a riffle, which is kind of like the bubbly part of the stream that flows over the rocks. But if we can't do that, then we'll do a vegetation sample or a woody debris sample, trying to collect given aquatic macroinvertebrates from the stream. And we try our best to ID macroinvertebrates and or fish in the stream. But if we don't know, we send it off somewhere to have someone else be able to correctly identify it. That way we know exactly what we're finding in the streams to better help us assess the water quality that we are finding in our streams throughout the entire state of Oklahoma. So over this summer, helping Blue Thumb and doing our fish collections and having our volunteers come along and meeting them, it's been great for me, just a little different experience for me. I've had internships in the past, but haven't done stuff quite like this. I've done some research in lakes, but not really rivers. So this has been great for me. And like you can see on the screen here now, if any research ideas that any students have or you have, you can bounce off of us. I believe our contact information is on the next slide. So reach out to us any way you feel fit. Look on our website. We'll be more than happy to help. And so love to hear back from y'all. And I think we have some undergraduate researchers next.
Great. Thank you so much, Blue Thumb. That was awesome information. And again, if you are located in Oklahoma, that's definitely a resource that you should check out. So now that we've heard about Blue Thumb and how their program works, I thought for faculty, it would be beneficial to see, again, how can we take that information and use that for citizen science research projects now? So I am luckily employed at Rogers State University, and we have capstone projects for our students where all seniors are required to complete a research project, and they take research methods classes. And I have two of my students from Rogers State today, and I would like them to share with you a little bit about how they've used Blue Thumb and how their participation in citizen science has helped them with the research projects that they're working on. So the first student that I'm going to let talk to you is Brittany Kincaid. So Brittany, the floor is yours now.
Hi, my name is Brittany Kincaid. I am an environmental conservation biology student at Rogers State University. I'm taking the Blue Thumbs data and I'm using it to not only assess the quality of the water, but how it's affecting the environment around it. And I'm focusing specifically on frogs, their development and their community diversity. The Blue Thumb Society has years and years of data collected, thankfully, from their volunteers. And so I can use that as historical data. So I can't just say that like this stream is good or bad right now, but that has always been that way, or it's become that way. So that's how I'm using it within my data. And it's very nice to be able to use that without having to do this research project for 2, 3, 4 years. I will be able to complete it in one summer.
Great, awesome. Okay, the next student that has a project that she's finished is Laura Haggerty. So I'm gonna let her talk a little bit about what she's done.
Hi, I'm Laura Haggerty. I'm a senior at Rogers State University in environmental conservation biology. And I also am a pathways intern with the Natural Resource Conservation Service and soil conservation. I did complete my capstone project, which was land use variability and flow variability in an urban multi-use stream. I had Blue Thumb training for the water quality testing, and then I also used Blue Thumb historical data because it was such a short window of time in which I was doing the actual testing. And I apply that every day with the NRCS. Agriculture is one of the largest producers of non-point source pollution, but water quality is also one of the greatest concerns for agricultural producers. I use it when we're talking with producers about nutrient loss, about pesticide application, watering facilities for livestock, and any kind of recreational usage for water sources on their property. And we also deal a lot with flood control, watersheds, and wildlife environmental preservation. And then I'll be joining the NRCS full-time in January, where I'll be a soil conservationist in my area. So it's not just that I volunteer with Blue Thumb and collect this data because I'm interested in what happens in this stream. And it's not just that I did it because I was interested in this for a research project. This is actually what I'm going to do with my career. And it affects not only myself and the people who live in my area, but also the people who produce the food that goes on the table of our citizens nationwide. So my data, if you'll flip to the next. So this was just a general overview of my data that I collected. The stream results we compared between sites and between testing dates, and then compared those with the historical numbers that Blue Thumb offered.
Awesome, good job, Laura. Last student couldn't be here today, so I'm just going to share very briefly about the work she's doing. Her name is Emma Stock, and she is actually out at Crow Creek doing macro invertebrate collections. And so she's working very close with Blue Thumb to try and compare macro invertebrate diversity to water quality. So these are just some various ways in which students locally have worked directly with Blue Thumb, a citizen science program, and have been able to take that data and incorporate it in their education as a project. So having said that, that is all of the information that we had for today. But I think to kind of sum it up, the thought of the webinar today is that citizen science really provides a great educational portal. And if you are interested, we have many panelists today from SciStarter, North Carolina State, Blue Thumb that you can reach out to for more resources. So like you saw with the SciStarter website, there is a list of potential programs or projects you could use in the classroom. Blue Thumb, I am sure, is happy to work with you. So after the completion of the webinar, you should get a follow-up email at some point, and we will give you a list of those resources and the recording from this webinar if you are interested. So thanks to all the panelists who came and spoke and represented your organization, and thanks to all the different attendees who came and heard us out today. I wish you guys the best.
And thank you to Cheyenne for being the fearless leader and putting all this together. I'm jealous of all you Oklahoma folks. You all get to do Blue Thumb.
Well, enjoy your birthday, Carolyn. Happy birthday again.
Woo! All right, bye everybody. Thank you so much.
Bye-bye.
Bye. Thank you, Cheyenne.
Bye, thank you so much.
Okay.